Hello and welcome to episode 30 of Daryl Show Your Work. In this episode, we're going to be working with TShark again, but similarly to what I did in another episode where I went over how to extract files from a Wireshark uh, packet capture, we're also going to do that here with TShark. All right, so to get started, we need to switch to the directory to where the pcap files are located. So I'm going to change directories here. All right, so I'm going to go here from my desktop and a little further into the files directory. And then we're going to be working with our file pcap underscore files. All right, and again, TShark works with with pcap files just like Wireshark does. All right. So the first thing we want to do is to be able to see only the packets here. Excuse me. Hold on. Before we do that, hold on. Let's make sure before I jump into that. This is we always got to make sure that our pcap files are actually in our directory. And let me see. I have a lot of files here, so let's just make sure that that's there. And let's see. Are you here? Let's go up a little. Oh, okay, I see. So it looks like no, okay, so these are all the files within the pcap directory. So we're actually in that directory. Okay, great. Okay, just wanted to double check that. All right, so the first thing we're going to dive into is how to apply some filters. So we know that on the when using Wireshark that we can apply filters on the search line. So we have to do a slightly bit different here with TShark since it's command line based. So let's try to work with a file here called http.cap, and we're going to filter just HTTP traffic. All right, so to do so, I'm going to say tshark -r lowercase http.cap, and then I'm going to do dash capital Y, and I'm telling it to only show me the HTTP packets within that file. All right, hit enter. All right, so we're seeing the HTTP packets here. We see some git commands, which applies some downloads. So this is what it looks like to how if we wanted to set a filter just to be able to just to look at some HTTP packets specifically. Now let's see if we only wanted to look at the packets that are actually carrying files. So now we're going to get into looking for a particular content. In this case, we want to look for only these HTTP packets that are carrying files. So we're going to do a similar command here, except where we have HTTP, we're going to add dot content underscore type. All right, and so all right, so this is what's going to narrow it down to the files for us. Let me All right, so by looking at this, we can see that specifically at packet 27, that we're looking at something that has some sort of HTML of code in it. So this is indicative of some sort of web page or file because it says text slash HTML. So there's a good chance that it's using some type of file within that packet. All right, so we're going to move further into this, and now we need to specify a certain package. So let's say we want to dive deeper here into packet 27 and want to see narrow in and see more about what's in that particular packet. All right, so we're going to put in a command here that is basically going to show a subset data, and we're going to print it using a B flag, which is verbose, and it's going to give us a lot of information about what's going on in this specific packet, the ID packet ID 27, um, and we'll discuss more about the input once I put in this command. All right, so we need to adjust our syntax a bit. All right, so we're going to change this, and we're going to change it to dash uppercase V for verbose. All right, and then we're going to put the Y back in there. All right, and then I'm going to specify the frame dot number, and this is going to tell it what packet we want to look at specifically. I'm going to say equals 27. All right, so we're diving deeper into packet 27 to see what's going on there. All right. So what we're actually looking at here is we can see part of the HTML in the web page included in this packet. However, there's some limitations. So only part of the HTML code here is visible, and we can only see the usable data, since HTML is the text-based protocol. So let's do a bit more digging to try to gain some more information out of this packet. So I'll just scroll up a bit just to show you that, basically we just see a lot of HTML code, HTML output here. All right, so nothing that's really all that human readable for us to be able to see what's going on with that particular packet and to find anything that could potentially be malicious. All right, so diving deeper into this, we're going to perform a hex dump of the other packet. So I'm gonna start that going, and then as we look at the output, I'm going to explain what it is that we're looking at. All right, so I'm gonna modify this a bit. So we're gonna take out the V, and then we're gonna place that with an X. All right, then I could have actually left the, you know what? Let me see. Looks like I lost the whole frame number thing. Okay. Anyway, okay. So, all right. I'm going to say frame dot number. I'm going to say equal 27. So now this is that adding that X switch. That's what's going to do the hex dump for us. All right, and then I'm gonna hit enter with that. All right. So what this is showing us is it's giving us a partial hex dump for packet 27 within this packet with traffic capture, and by printing out the entire HTTP download session, filtering out the packet headers and converting hex characters into raw bits, a full file can be extracted from this. So that helps us to dive a bit deeper into this, but we want a little more information. So let's start trying to export objects. All right. So in order to do that, um, we first need to see which export protocols are supported by TShark or our TShark instance. So gonna go back a bit, and then we're gonna run a script here. We're gonna run um, export dash objects, and then space, and then period. So this is going to give us a list of what supported export protocols are within TShark, so we can make a decision how we want to try to export some things that we find out of here and then perhaps to our local directory. All right, so we have quite a few options. We have FTP, data, HTTP, SMB, and TFTP. So let's say we wanted to work specifically with the HTTP protocol. So we're going to dump some HTTP objects from our packet capture into a directory. We're going to create a new a folder called dumped. All right. So on our local directory, we're going to output some of the HTTP objects from this packet capture into a new file. All right, so we're gonna dump the objects and create a new folder all in one command. All right, so backing up a bit here. All right, so now we're going to add a Q flag, and so what this Q flag does, it's basically it's going to suppress TShark's usual output, which will print the summary information of all packets, and we're just going to tell it to just give us the HTTP package from this HTTP cap file. So that's what this Q is doing. All right, then we're still going to have the export objects. All right, objects script in here. Then we're going to specify HTTP. All right, and then we're going to tell it to create a new directory called, put it in a new directory that we're creating called dumped. All right, so checking my syntax here. All right, we should be good to go. Let's see if TShark agrees. Okay, I didn't like something that I did, so let's see. Okay, I think I may need to, let's see, backspace that. So there shouldn't be a space there. Now let's try that again. There we go. All right, got to make sure our syntax is tight. Okay, so um, the next thing we're going to do is we're actually going to look at what we dumped into our local directory here, and we're going to try to find some packets of interest. So in order to do that, I am going to be working with another file, and we're going to work with a file called the multi-stage pcap. And what multi-stage pcap is, a pcap file that includes the traffic captures from a multi-stage malware infection. So we already know that we're going to, and with this particular file that we're going to be working with, that we actually did have an active infection, and we're going to be trying to narrow down, okay, what particular file or what particular actions may have kicked off this malware infection. Where did stage one happen? All right, and we're going to say http dot content type. All right, because those are the file, those are protocol types that we want to search for. All right, so just checking my syntax here again to make sure we're good to go. All right, hit enter. Okay. Oh, forgot the I out of multi-stage. Okay, so let's. All right. Oops, wrong place. Man, this thing. I'm sorry. This thing is. All right. There we go. All right. All right. So we got a lot of output here. So um, let's dive into this a little bit. I'm gonna scroll up. Okay, hold on. Okay, let's see. Permission to capture device. Well, okay, that about to say, I thought that output looked a little funny. So let's see what's going on. Did it not like something I put in my syntax again? And it looks like I forgot the R switch out of there. That's what it doesn't like. All right, so let's. Sorry, my lab is moving a bit slow today. All right. All right, so I need to go back here. Okay, and we have to specify multi-stage with the R switch. All right, so let's see. We should be okay now. Let's try this again. All right. So now we got some packets here. Okay, so let's go up a little bit. We have a lot to look at. Okay. So if we look at the very this very top packet ID 323, we could see that MS Word was actually used. Some sort of some type of download or something happened with an MS Word file. So we know that could be problematic because some versions of Word actually allow something called macros, or allow if it's not disallowed, or if that particular function is not disabled, it can allow macros or other functionality that acts as a download for future stages. So just know that macros tend to be they run active code within Word files. So that's something that we may want to investigate, because we don't know whether or not that feature within Word was disabled. So based on that assumption that we don't know whether or not that is true, we're going to move forward with digging a little deeper, specifically into packet 323. All right. So the next thing we're going to do, we're going to try to view the contents of that specific packet, which is 323. So we need to adjust our TShark command here a little bit. All right, so we're going to be we're going to leave the Y switch in here, and we're going to be asking it again for a verbose amount of information. So we got to add our dash V in here. All right, then we're going to leave Y. And now, similar to before, when we were working with the HTTP file, we're going to say frame.number, and we're going to specify um, what was it, 323. All right, so we want to dive deeper into that packet um, to look at what's going on there. And so it's going to give us a lot of output, but most of the things that we're going to be looking at is going to be right here, kind of towards the tail end. So the first place we want to look at here is in content disposition. So we see there's some type of attachment in the file name. It confirms that, so it's something called USPS invoice reggie.cage.doc. So we know that we're dealing with a Word file, because that's the format that Word file saves its files in is a dot dot. So another interesting thing here to look at is the content length, and it appears to be 204,228 bytes long. So that's awfully big for a Word file, but probably what this more than likely means is that this file was actually sent and different and broken up into several packets. It wasn't just sent into one large packet. Usually when it's this big of a content length, it was broken up, and probably broken up that way to try to circumvent, any sort of firewalls or anything like that. If you remember the last video, we went over fragmentation. Could be an indication of what's going on here. And then if we go a little further down, we see a URI request. And so this tells us a domain that it came from. So it looks like it may have come from a Japanese domain. And if we look at the ID here, it seems to indicate that this part, this CMVN, this long thing here, this actually may be the original file name and not this US invoice Reggie Cage doc file. Somewhere along the line, it may have been renamed. Since we haven't where it says ID equals, and usually this is an indicator of the source file. All right, so to move forward, we just like we would do in on Wireshark, when we find something, we want to be able to follow and to view the TCP stream. So to first for us to directly search or for the stream index number that this particular invoice file may be in, we need to run a command. So the next command that we're going to look at to find that particular stream, all right? So we're going to go back here a little bit, and we're going to leave the V and the Y in there. As a matter of fact, we could have left um, frame number, because we're going to be actually be adding to this. Because what we're going to do is we're going to actually grep for some specific information um, within this output. So we're going to grep, and we're going to say any place where it says stream. All right. So that way we have this long output, and we just want to see any area that kind of points out to us that's indicative of a stream. All right. So we want to be able to narrow down what we're looking at by that. And you know what? And it told us that the stream index number for this, it appears to be 0. All right. So, and hold on, let me make sure that, because it looks like I should have put 323 to make sure. Made an error there. Make sure that everything else here is good. That is giving me the right ID for this. And it still says 0. Okay. So the next thing that we need to do then is that we need to actually look at the contents of stream 0. All right. So we're gonna modify this a bit. All right. And then we're actually going to add Q back to here. Right, to this, not to return us so much information. All right, then we're going to work with lowercase z, and then we're going to say, hey, we want you to follow TCP stream, and then we want you to give it back to us in ASCII format, and we are specifying it's not quite as many characters in the word ASCII. All right, there we go. And we want you to show us the contents of stream 0. We want to pipe that. I'm going to say head. so minus 100. All right, and this is what's going to allow us to specifically see what's going on inside of a TCP stream ID 0. All right. All right, so we see there's a lot of gobbledygook here, and not really a lot of a readable language here. So it's looking like we're probably going to have to dump this file and for further investigation. Because I mean, this is telling us like a whole lot of nothing. All right, let me bring this back down. Seem like these large outputs are causing my virtual machine to run slow here. So bear with me. Boy. You know what? I may have to, there we go. Okay. All right. Sorry about the technical difficulty there. All right. So, all right. So the next thing we're going to do is we're going to try to dump these the contents of this TCP stream. We're going to try to dump this into a file on our local directory. All right, so the first thing we're going to, in order to do this, we're going to change some commands together. So the first thing that we need to do is we're going to we're going to write a command to write to a standard output, and then a second command to be able to read the read from the standard output before we can begin to dump it. So in order to do that, let's start chaining the different commands together, and I'm gonna show you what I mean by chaining it. And then we're gonna take this queue out. All right, so again, right now we're adding a command for it to write to a standard output. All right, then put dash, then put dash y, then I'm gonna say frame that number, because we're still working with frame 323. We're just looking for the specific TCP 0 ID in there. All right, so TShark. All right, and now we're adding that. We're chaining that together with the read. Okay, so again, what this is going to do is going to set um, the first command to write to standard output, and then the second command to be able to read the standard input. That way, we could kind of, when we dump the file, we could kind of better be able to interpret what we're seeing here. All right, so I'm gonna hit enter. Hopefully everything is right with that. Let me see. Okay, there we go. Okay, all right. So it looks like that worked. All right. So then now what we want to do is we want to be able to, in the next step, we want to be able to filter out the TCP session 0, and then we're going to save that to into a new directory called a docs directory. So we're going to again create a new directory on our local directory and store this file into there. We're going to name um, we're going to keep the same file name, but we're going to again put it into a different directory. So in order to do that, we're going to tweak this command here, and it's still using frame number. We're going to keep everything the same here, but are we going to say TCP, and we're specifying the TCP stream that we want to see the contents of within this this packet 323. All right, then we're going to pipe that, and then we're still giving it the reading ability, and then we're going to add this queue to kind of narrow the output down a bit. All right, then we're going to say export. We're going to run this script again, export objects. So we're still chaining. So we went over a few of these already before in this video. Now we're kind of chaining everything together to get us the output that we're looking for. All right, so we're saying we wanted to export just the HTTP objects, and we wanted to put it in the docs directory. All right, so I'm gonna hit enter. Okay, it's in like something that I wrote. Oh, well, I wrote track instead of TShark here, so let me tighten that up. All right, let's try to run that again. All right, so let's see. Let's look in our local file directory and let's see is that well, let's hold on. First thing we need to do, we need to change directory to docs. So let's cd docs. All right, and that's looking at docs directory just to make sure our file is there. See, so this is what I was saying. So even though it's the same file that we're working with, it doesn't have that USPS .regi.docs file name. It's going to give us the original file name that we found when we looked at the original uh, request to the request to that primary web directory that was in at first, and it's basically going to give us that particular original file name. So this is still that regidoc USPS regidoc file, but it's going to just give us this the original name of that. So so the thing we want to do with that is, let's say I need to copy this because it's no way that I'm going to try to write all that out in my next command that I'm going to write here. So we're going to try to display the contents of this file to see what else we can find. All right, so in order to do that, I'm going to say more, and then I'm going to say docs. Well, we're already in docs, so I'm going to just putting that should be enough since we're already in the docs folder. All right, and I'm going to hit enter. and this should be able to show us what's inside that file. So again, a lot of gobbledygook here, but this shows that the main thing we're looking for is to verify that Microsoft Office was indeed used to um to make this file. All right, so this kind of goes into what it is that we were looking for, just to verify that, hey, that this is indeed the same Word document that we can use. And then what we could do is we could do some further verification of this extracted file by, I'm going through my history here. All right, and so we're going to change, instead of saying more, we're just going to say file, and this should tell us a bit more about the file that we're using. You know what? I'm gonna just make life easier. Let's just clear this all out. So clear, writing clear clears that all out, because I don't know, seems like my my virtual instance here is on the verge of having a stroke. So I'm gonna write file, and then not do that. Okay, so it just kind of gives us some information about the file. So if we go here, it starts to tell us that see right here, create a name of creating application, Microsoft Word. All right, and then it tells us that the author is someone named Matthew. All right, so we got a little bit of information from who created this file. So we know that now that this was indeed the file that started off the malware incident. And I mean, this is just, I mean, we're not going to dig any further than that, but this was just to show how we can use different filters within TShark to help with investigations, to try to get to the root of a problem when doing some investigation, and when trying to go back and see, okay, after we've kind of resolved the incident, and and try to go back to see, okay, what happened, doing some further investigation and digging. This is how we could use T-Shark to do this, by chaining different commands together to be able to extract a particular file that we found within the packets coming into our network, and then studying the attributes of that file to then be able to gather a bit more information to tell the story about what happened. And we can see in this incident that somebody downloaded a Word file from a looks like a Japanese URL, and then that appeared to be malicious, and it was then written by someone named Matthew. And again, it was a Word file, which probably means that our organization does not have a policy where they automatically disable macros by default. And that would probably be a recommendation moving forward, that, hey, don't allow macros, because malicious files in the form of Word documents can come in and allow executable code. Well, anyway, that's going to bring us to the end of our video. Please like, share, subscribe. Most importantly, show your work. And until next time, take care of yourself, and God bless.